what I notice here is it tells me factor completely, and I have the first one, it's a trinomial. So trinomials, traditionally, you're trying to get into these binomials. Okay? Well, how do you know if you can factor it? Well, you take the highest degree, which is what, class? What's half of 3? This has to be 1.5. Is this 1.5, class? So the answer for the first one is not factorable or prime. Think about it. If the problem says something like this, let's just say you put into your binomials and you're guessing and you put something like x squared times x. Yes? Well, x squared times x is how much? X to the third. That's getting what you want. But let's just say I put in some random numbers here just to prove a point. And then you're multiplying by using FOIL. Then you'll get the outside terms as x squared. And then you'll get something like negative 2x minus 2. Do you see that? Do you see how you're kind of skipping a term? And that's the reason why this problem is not factorable. It's prime. Over here, later in today's lesson, you guys are going to learn about it when I have two terms. Everyone say two terms? Count with me. Ready, set, go. They call this a binomial. You're looking for binomials to have a subtraction sign so that you can use the difference of squares. Okay, or a highly more difficult one is a difference in sum of cubes, which you probably haven't seen since last year. But if you rewrote the problem like this, x to the 8th plus 0x plus 25, class, what's half of 8? 4. Does that say 4? Prime factor. Can't factor. Take a look at this problem now. I have 4 terms. And in my 4 terms there, I'm going to do something called factoring by grouping. Factor by grouping. It's a method. This is not what I traditionally teach in my class, like Xbox or different squares. So look at the problem here. I'm going to notice over here that they has a greatest common factor. The greatest common factor is a 9, a positive 9. I'm left with x minus 2. I want to pay attention to both of these terms because I'm hoping over here when I factor this side, one of them will be one of these. If I take out my greatest common factor, what do I get, class? X squared times x minus 2. Okay. If I'm paying attention, I realize that on both sides of the plus sign, they both have an x minus 2. So what I'm doing here is a second greatest common factor. I found a greatest common factor on the left side. I took a greatest common factor on the right side and on the left side. And then when I look at it, I realize they both have another x minus 2 in common. So I have x minus 2, and then I'm going to write everything I did not highlight. So I have x squared plus 9. And this would be your answer. Our answer is orange. So this is a method called factoring by grouping. And you can actually double check your answer. Let me show you guys how to do that. This whole quantity times x squared is the quantity times x squared. This quantity, the whole thing, times x plus 9 is this term up here. So you're kind of recognizing, and if you did FOIL, you would actually get this above. Okay, but this is a method called factoring by grouping. All right, last example here. 5 minus xy minus 3 times y minus x. In the previous problem, I recognized they both have an x minus 2 as my greatest common factor. Down here, they're not exactly the same. Let's just say you switch this. Let's just say you have something like negative 3 times negative x plus y. That's okay to do, right? Because the math operations are still the same. You see that? This negative 3 I'm going to pull out here. And in the parentheses, I'm going to factor out a negative 1. So ignore the negative 3. Negative 1 times something equals negative x. That'll be x. negative 1 times something equals a positive y. What is that, class? Negative y. So I factor out a negative 1, and you can always distribute to check your answer. Okay, so when I put it back into the problem, 5 times quantity x minus y I'm going to put all of that right here. This is negative 3 times a negative 1 times x minus y. I'm just going to go through and simplify now. I have 5 times x minus y. Class, what's negative 3 times negative 1? Positive 3. And I have this xy. Normally, students are tempted to distribute here. But look at what the directions say. The directions say factor completely, not expand. Expanding would be back in standard form. Does that make sense? We're just trying to condense it as much as possible. So here, this is as similar as something like 5m plus 3m. Do you see that? These are like terms. You can add those. You just add the coefficients, and you get 8m. So here, I can combine like terms. I'm going to get 8 times the quantity x minus y. And this would be my answer. So here are 4 examples of different types of factoring.